We talked about last meeting the compounds saturated and unsaturated. Aromatic compounds or aromatic hydrocarbons are actually an example of unsaturated where we could see double bonds later on, just like alkene and alkyne. As you might think because of its word, aromatic might have an aroma, an essence, or a smell perhaps. Yes, you are right because aromatic compounds really have a good smell. The scent of fruits, perfumes are aromatic, and before even the chemists understand the structure of these compounds, they have called it aromatic because they have this great scent along with them. For the focus of this discussion, we will talk about how we could identify the aromatic compounds based on their structures. Next, just like the previous lesson we will understand their physical state at room temperature, and lastly, we will further know some polyaromatic hydrocarbons. Poly means many, and so these structures are of many aromatic structure in them. If you are ready, fasten your seatbelt and let's get started. There's always one structure that always came up when we talk about aromatic structure, and that is the structure benzene. Because aromatic compounds are actually unsaturated cyclic hydrocarbon that does not readily undergo upon addition reaction. Aromatic compounds is any compound that has one or more benzene-like ring. That is why it is considered benzene as the simplest aromatic hydrocarbon. To have a small history about benzene, benzene is actually isolated by Faraday on 1825 from coal. And so he discovered that this compound is very unreactive and they are stable structure. They actually analyzed this compound and found that this compound has formula C6H6 in their structure. However, they doesn't know how it actually looked like in its structural form. Several years later, some of the scientists came up of this formula. If you can see here in the structure, it is actually true that this is C6H6. As we count each of the atoms in this compound, we have here number of carbon. Let's count 1, 2, 3, 4, 5, and 6, and this is C6. And then in the hydrogen, we could see that this is 2 hydrogen plus another one here, so that's 3, 4, and another 2 constituting to 6 hydrogen. Therefore, this is true based on the scientists that this is the structure of benzene having the chemical formula C6H6. But scientists wasn't that convinced on this structure. They feel that there's something wrong about this structure. One thing also why they are not satisfied with this is because benzene, as they know, is very unreactive. And this structure is very dense. There are a lot of dense areas, and thus there are also a lot of sites where reaction could take place. Aside from this truth, this structure behaves very the same with alkanes, and benzene doesn't behave as such. This is where Kekulé in 1865 proposed this structure, a cyclic with 3 alternating double bonds. So how he discovered this structure? He was actually has a dream. While he think different structure, he fall asleep and have a dream, and this structure pop out in his head. A cyclic structure with double bonds with them, and it actually fit considering also that about Faraday formula, which is C6H6. You can also write this one as such. So as you can see in here, we can see that there are 6 number of carbon and 6 number of hydrogen. But according to the scientists, this still was highly reactive. And so, Pauling discovered in 1930 and proposed this idea of hybrid orbitals and resonance structure. resonance structure are actually not fixed. They are actually delocalized among the structure. So he put that idea and put it in benzene. And so, instead of being a fixed structure like this, he delocalized the double bonds in which some of the double bonds will go here, some of the double bonds will go here, and here. So what is actually the bonds are doing is that they are switching around the structure. So one bond will go here, another bond will go here, and then so on and so forth. It's like the electron are floating on top and not fixed on the structure. So instead that the carbon has a particular bonds, they are sharing all the valence electron towards the structure. That will look like a ring. So this is actually the true form of benzene and the backbone of all aromatic compounds. Other scientists also name the aromatic hydrocarbons as arene or aryl hydrocarbons. Some of the aromatic hydrocarbons are not only consisting of one benzene, but some are consisting of two benzene, like your naphthalene, or with more than two benzene rings like the benzopyrene. And these all of the structure, regardless of how many benzene ring they have, they called as aromatic hydrocarbon. To summarize, for us to know if the structure is aromatic compound, we always look for the benzene structure. Could it be like the one presented by Kekule or the one presented by Pauling? Anyways, the two structure still is considered this day, only that the Pauling's discovery was more accurate compared with Kekule. Let's now have a exercise regarding in identification of aromatic hydrocarbons. You can stop first this video and then answer in a piece of paper what are the following structure. Could it be aromatic or not an aromatic hydrocarbon? In the first example we can see here, this is a 4 carbon ring with double bonds in each of the side. So again, our aromatic hydrocarbon has chemical formula C6H6, which has a ring or which has a 3 alternating double bonds. So therefore, this type of structure is not fit in our aromatic hydrocarbon. Therefore, this is not an aromatic hydrocarbon. The next example we have here is, we can see, though it has an attachment, we could see a 6 carbon with alternating 3 double bonds. Therefore, this is an example of aromatic hydrocarbons. In our next example, again, aromatic hydrocarbons are a 6 carbon ring consisting of 3 alternating double bonds. But in this example, or in this picture, we could see only 2 double bonds. Therefore, this is not considered as aromatic hydrocarbons. Similarly, also with our next example or next picture here, we could see a 5 carbon ring and consisting of 2 double bonds. So therefore, this is not an aromatic hydrocarbon. Next example we have here, we see a ring which is proposed by Paulings and 6 cyclic hydrocarbon. Therefore, this is considered as aromatic hydrocarbon. Next example we can see here is that there are 10 carbon with alternating double bonds. Since therefore this is a 10 carbon hydrocarbon, therefore this is not an aromatic hydrocarbon. Pretty easy, right? Let's proceed now with the physical state of aromatic hydrocarbons. Aromatic hydrocarbons has only 2 physical state, which is the liquid and solid, because the simplest aromatic hydrocarbon or benzene is actually a liquid and not a gas, though they are very reactive with the temperature, and that's why if there is a high amount of temperature, higher than, let's say, higher than the room temperature, they can easily go as gas. However, if we say that physical state under room temperature, there is no gas for aromatic hydrocarbon. And then the simplest aromatic hydrocarbon, which is the benzene, is actually a liquid, and also all of the monosubstituted and disubstituted are liquid. While if there is 3 or more than substituted benzene, we consider that one as solid. Let's have now a practice exercise. So you have to encircle the compound if it's liquid and box the compound if it is solid. We did not consider here a gas because again there is no gas for aromatic hydrocarbons under room temperature. First example, we have a benzene having one substituent. So therefore this is a liquid. And then here we can see 3 substituent, therefore this is solid. Another example, we could see here 1, 2, 3, 4 substituent, therefore this is a solid. Another example, we could see 1 substituent and then another substituent, therefore this is a liquid. Wala siya na ansiran. So let's just imagine there is a circle here. Next example we have here, having only 1 substituent, therefore this is considered as liquid. Oh, there's the answer now. So the 2 of them are considered as liquid. Next example, we have having fluorine as their attachment, which is consisting of 1, 2, 3, 4, 5, 6 fluorine. Therefore, this is considered as solid. That's it for our physical state. Let's proceed now with our last topic, which is the polyaromatic hydrocarbons. So for the polyaromatic hydrocarbons, you just have to remember all of the structures we have here. So for example, again, since that is a poly, meaning there is more than one aromatic hydrocarbons within one molecule. So if they have 2 aromatic hydrocarbons in their structure, that is considered as naphthalene. If for example, there is 3 attachment which are horizontally or just like a straight line in them, the 3 are on a straight line attaching to each other, that is considered as anthracene. If for example they have 3 benzene ring or 3 aromatic hydrocarbon with them, but they are not on the straight line, so we considered as phenanthrene. And then if there are 5 aromatic hydrocarbons, we considered as benzopyrene. Let's have now an exercise regarding polyaromatic hydrocarbons. So let's just identify what are the names of these polyaromatic hydrocarbon. So the first example we have here is having 2 aromatic hydrocarbons in their structure, therefore this is naphthalene. The next example we have here is we have 3 aromatic hydrocarbons in their structure, however they are not on straight line, therefore this is considered as phenanthrene. Next example is aromatic hydrocarbons having 1, 2, 3, 4, 5 aromatic hydrocarbons in their structure, therefore this is benzopyrene. Our next example here is having 3 in which they are horizontally attached with each other, therefore this is considered as anthracene. And this is also true with our last example. This is still considered as anthracene. That's it for our aromatic hydrocarbons. I hope you learned something out from this discussion, and if you have any questions, you can always message me. Hanggang sa muli, paalam!